In this section, we're going to use the fault pattern diagnostics that we just used with lighting on computer control components. They also require B+ and ground to operate. We're going to focus our analysis on getting the proper ground and B+ to a number of components and show you how we're going to use the exact same technique on the diagrams we used before. Now, for training purposes, we made our drawings for ourselves because the information was spread over 5 pages and we wanted to focus on the fault pattern diagnostics to show you how they work. Computer controls are going to add us another slight layer to the diagnostic because we have to understand how some of this works. One of the ways we're going to do that is looking at things like coil on plug and how the computer plays a part in supplying the ground. We'll start with an ignition system for current flow analysis and talk a little bit about ignition systems. Some ignition system coil basics. Coils are actually transformers. The coil primary and secondary are magnetically coupled. So the point we're making is secondary voltage is generated by the magnetic field, which is created by primary current flow. It's all about current and magnetic fields. A weak spark will result if the primary current is lower than normal. Let's break it down again just so we understand it. Primary current is a result of the voltage applied to the coil, the coil resistance, which has to be normal, and the ground provided by our forward PCM in this case. Let's go back and talk about ignition operations. We'll go into this later, use the lab scope patterns, and we'll use those to get detailed information about what's happening with the spark. The length of the spark is the result of the magnetic field collapsing when current flow is interrupted. The strength of the magnetic field is determined by current flow in the primary. So let's look at this. Here's our Ford coil on plug. It uses the magnetic field collapse for ignition. The magnetic field is a result of current flow. So let's talk about and look at the schematic and analyze our current flow. First, we've got B+ applied from a fuse over here. It's applied equally to all 8 cylinders. First question, do you have all 8 cylinders affected? Well, this is one of the things that are common. Do you have 4 codes? If you'll notice, this is divided into 4s at each splice. We could have 4 go bad on one side and not the other. So this is information we're going to be using in pattern analysis, just like we did light bulbs. How many things are being affected? And remember, low B+ will cause low coil current, which gives us a weak spark and may result in misfire codes. Sometimes we have to take it back, and here's an example how we take it all the way back to battery B+. So you can take it all the way through. Now the second thing is we've got to look at ground. We've got to have B+ on one side, we've got to have ground. This is our second element. Ground is supplied by the PCM. It goes all the way down here, and a PCM cannot give a ground unless it has a good ground. So we have to have a good ground on pin 77 and 76 down here in order for the computer to supply ground on all these coil on plugs. So that's a primary thing. A bad ground will cause coil to be lower than normal. Is it lower on all cylinders? Again, this is a possibility where all cylinders have weak spark, possible misfires. Here's another area where it can be common. An area sometimes missed by people because they beat up on the power side and forget the ground side of this. And the last thing we're going to have, high resistance in the coil is going to cause current flow to be low. Now the difference here, a bad coil is going to be one specific cylinder. It will not be common to 4 or 8 like the B+ or the ground, which will affect all cylinders equally. So you see, the pattern's the same thing. Now we're going to use the same fault pattern analysis. Are all cylinders affected? Do you have multiple misfire codes? Do you have problems with engine performance? Here is where you come. Yes, it takes a little more. It's got extra stuff because we have a computer supplying ground, but it is still basic light bulb technology. The only thing that's changed is we have a computer supplying ground. We have a coil instead of a light bulb, but the product is the same thing. We still have to have power and ground to make it work. Let's go look at some other computer control things and pay a little more attention to grounds and the type of ground distribution we have in computer controls.